going to be working on page 218. The average height of men in the United States is 69 inches and then 3/10 of an inch. The average height of women in the United States is 63 inches and 8/10 of an inch. How much taller is the average man than the average woman? So here we're just going to do some subtraction. So we're going to write our number model here. We would take 69 and 3/10 and subtract 63 and 8/10, and that would tell us how much taller the average man is. It does not mean that this is true for everybody, it's just an average. So we would subtract by lining up our place values and the decimals, regrouping when necessary, and we would bring down the decimal. So the average man is about 5 5/10 inches taller than the average woman, or about 5.5 inches taller. What is 11/12 of 6? Well, of means we're going to multiply. Put that 1 underneath the whole number, and we'll get 66 over 12. But that's improper, so now we need to divide. And this is where your math facts come in handy, because it helps you divide quicker. So the, I was going to say the average, oops. So 66 over 12 is the same as, oh my goodness, that focus is terrible, is the same as 5 and 6/12, but it could go even smaller to 5 1/2, because 6/12 is the same as half. That's the equivalent fraction. So I would take either one of those two, 5 6/12 or 5 1/2. A library spent 5/8 of its budget to buy new books. They set aside 1/12 of the book money to buy young adult novels. What part of the budget went towards buying young adult novels? So 5/8 of their money, they're going to buy books. But part of that 5/8, 1/12 of that, they're going to buy young adult novels. So how much of the total budget, or how much of that 5/8 budget is going to those novels? I'm going to put N for novels. Here we just multiply straight across. 5 times 1 is 5. 8 times 12 is 96. So this here is a very small amount. 5 out of 96 of the 5/96 of the budget will go towards young adult novels. Here we have some subtraction problems. You're going to want to convert to improper fractions first. Remember, we take our whole number, we multiply it by our denominator and add it to our numerator. 3 times 4 is 12, plus 1 is 13, keeping the denominator the same. 1 times 6 is 6, plus 5 is 11. Denominator stayed the same. Now I need to list the multiples of the two denominators to find my least common multiple, and I'm going to use my scratch paper to help me. So I have 13/4 and 11/6. My denominators are 4 and 6. I'm going to count by 4. I already know my denominator because I'm pretty good at my math facts. You might be able to figure it out without listing the multiples as well. It's 12. I have to take 13/4 and multiply it by something to get 12, which would be 3 over 3, which would be 39 12ths. And then my second fraction is 11/6 times what gives me 12. Even when we know this, it's important to do it because we don't want to skip steps. When we skip steps or do them in our head, that's when we make our mistakes. So my next step is to substitute. So 39/12 minus 22/12. Well, what's 39 minus 22? Subtraction there. My denominator stays the same. So it'd be 17/12, which is improper. So I'm going to take 17, divide by 12. 12 goes into 17 one time, making 5 my numerator, 12 my denominator, and 1 my whole number. So what is 3 1/4 minus 1 5/6? It is 1 5/12. We could not have solved that without finding a common denominator. Now I have 6/7 minus 5/9. And this is where I can think about my multiples and where knowing my math facts comes in real good handy here, because my multiples, I'm going to have to count pretty high to find a common denominator, but I know it's going to be 63. So I need to think about 6/7 times what gives me 63, which is actually 9. What we do to the denominator, we do to the numerator. So 6/7 is the same as 54. Then 5/9 times what gives me 63, multiplied by 7. Now I substitute. So now I'm going to take 54 63rds and subtract 35 63rds. I'm going to go back to my graph paper and remember, or my scratch paper, not my graph paper, and remember that when necessary you need to regroup. So we have 54 minus 35. We're going to subtract when necessary, or regroup when necessary. 19 is our numerator, and 63 is our denominator. Now if you're thinking about this, is this fraction simplified? Well, we'd have to think about what multiples go into these, or what factors go into these numbers, and 19's prime. So if 63 could be divided by 19, that would tell us if this number is prime or composite, or not composite, sorry, simplified or not, but this is simplified. So 19/63. Write this number in decimal, write this decimal in expanded form. You could use the back of your book, but this number is 1,072 and 39 hundredths. 39,000, sorry. So the back of the book can help you. I'm going to do each digit times its place value. So 1 times 1,000 plus 7. Well, what place is the 7 in? It's in the tens place because there's nothing in the hundreds place. 2 times 1. Nothing in the tens place. There's a 3 in the hundreds place, so 3 times 100 plus 9, which is in the thousands place, times 1,000. So that's how that one looks there. Write this number in word form. So I have 1,000. I like to just kind of go slow when I do this. That was in front of that first comma, or the only comma. Now between the comma and the decimal, I just have 72. So 1,000, 72. Then I have a decimal, which we write and. Then I have the number 39. And the place value of that 9 is in the thousandths place. So if I were to read that number to make sure I have it correctly, it would read 1,072 and 39 thousandths. Alright, our next one we're going to solve. It's just multiplying by powers of 10. 10 to the power of 3 is 1,000. So that's moving my decimal 3 times. So 1, 2, 3. So 25 thousandths minus, or multiplied by 1,000 is just 25. Then I have 25 hundredths here multiplied by 10,000. So I'm going to move my decimal 5 times, but I need to annex some zeros. So 1, 2, 3, 4, and 5. My goodness, lots of moves there. So then that 25 hundredths becomes 25 25,000. That's like having 25 cents and multiplying that 25 cents by $10,000. That would be pretty amazing, huh? Alright, our next one here is going to be 2 and 5 tenths multiplied by 10 to the power of 2, which is 100. So $2.50 multiplied by 100, or you're increasing that 100 times, would be move it once and then move it twice for 250. Our final one is 25 thousandths multiplied by 10. We're just going to move that decimal one time, and instead of we have thousands now, we have hundredths. Alright, great job. Make sure that you show your work on all of those.